array made on your desk, as well as it drawn in your agenda. Sorry guys, problem solved. You can figure out what I meant to say. As well as in your notebook. What equation goes with this array? What multiplication equation fits this array? Susie? I don't know. I have an array. I need to know what that is. This array represents 2 times 2, which we could say 2 groups of 2. 2 skip counted 2 times. What's the product of 2 times 2? Cheyenne? 4. I want you to add another group of 2. Another group of 2 to your array. What do I have now? What do I have now, McKenna?
6.
No, that's not a multiplication equation.
You have 2 times 3, or 2 groups of 3.
Which equals?
6.
So I have now 2 groups of 3, 2 times 3, which equals 6. Add another group of 2.
Ooh.
Natalie's arranging her array using the yellow counters like I've asked Gabriella vertically. But mine is going side to side. Can she do that?
Yes.
How do you know she can do that? Her array is going up and down, but my array is going side to side. Is Natalie right? Am I right?
Yeah.
So how do you know you can do that? Ryan? The commutative property. Math point for you. Well done. Yes, I can change my array. Does my product change whether I make it go up and down or side to side?
No.
No, it doesn't. All right, what's my math equation now, Georgiana?
Two times 4
Equals
8.
add 2 more counters, another group of 2. I'm going to add mine to my front because I'm running out of room. Alright, what do I have now? 4?
2 times 5.
2 times 5, which equals?
10.
What are we starting to notice about these equations? You have 2 times 2 equals 4. 2 times 3 equals 6. 2 times 4 equals 8. What are we noticing? What kind of relationship are we starting to see? Aiden, what are you starting to see?
We're counting by 2s.
Okay, so when we do our multiples of 2,
And also, I have another, I made an observation that every time we added 2 more, I wrote all my groups right on top of each other, and it looks like if we did 2 times 1, it would make it, if you look at the answers for it, but if we first started with 2 times 1, it would be 2, 4, 6, 8, 10. So the answers combined it.
Yeah, so when we go through our multiplication in order, 2 times 1, 2 times 2, 2 times 3, we have 2, 4, 6, 8. What else are you noticing? What else are you starting to notice? Kaiser, what are you noticing?
That they're all even numbers.
They are all even numbers. Go ahead underneath where you've drawn your arrays. I want you to write things I notice. And I want you to start writing some of these things down that we're noticing. So so underneath your arrays, I want you to write things. Alright, so Aiden gave us that when we've arranged our equations, or skip counting by cubes. Have you ever noticed that all the products are going to be even? 2, 4, 6, 8. What else can you tell me? What else do you notice? Gabriella, what do you notice?
I noticed that every time we do the we count, every time we add the counter and the counter, I noticed that each time we made a number, first we started at 4. I noticed that we were counting by 4 that we have to equal.
We're not counting by 4s. We're not counting by 4s. Grace, what do you notice? Sure. Sure. Natalie, what do you notice?
If when we're doing 2 times 3, it would just be doubling.
You are doubling one of your factors. Think about the rule for 1. Turn in your notebook to when we wrote down the rule for knowing our 1. What's the rule for when we multiply 1? Courtney, what was the rule for multiplying by 1?
Anything that is times 1 is itself.
Anything times 1 is itself. So 9 times 1 is 9. Anything times 2 is double. Anything times 2 is double. So what if I did 3 times 2? What's going to be the answer? The product, I guess I should say. Damien?
6.
6. That 3 gets doubled. So anything, great observation, Natalie. Anything times 2 is doubled. And then we can write our example. 3 times 2, that 3 doubles to become 6. We can double. I want you to make a 1 by 6 array only using the red counters. A 1 by 6. Think about what that looks like. I want you to make a 1 by 6 array only using the red counters. Think about what that's going to look like. Aiden, that's not a 1 by 6. Remember rows and columns. Think about how we make an array. So you could have your array going vertical, you could have it sideways, but it needs to be one chain of 6.
I did that.
I'm going to make mine sideways.
I made mine.
And we just talked about why it can go vertical or sideways
Commutative.
because of our commutative property. 1, 2, 3, 4, 5, 6. Whoa. Alright, now adding yellow counters, I want you to make this 1 by 6, I want you to turn it into a 2 by 6. Just adding yellow counters to what you've made. Where are you going to put yellow counters next to your 1 by 6 to make it a 2 by 6? Good, Brian. Good, Lucy. Cord. Knock the tower. Sorry, friends. We're not doing towers. Good, Natalie. Good, Mason. Good, McKenna. Yeah, we're going to take our yellow counters. We have a 1 by 6, so to make a 2 by 6, we just need to add one more group of 6. 6 more. So your array should look something like this. Can we see how we doubled it? We had one group of 6, which was 6. Then we doubled it to be, Sam? What? 2 by 6. What's the total? What's the product now? 12. We had 6. And then we added another group of 6, which doubled it. And so now our 2 by 6 is doubled, equals 12. Brian, what's up? You were going to say that. Yeah, Natalie, what's up?
Is when you're doing 2 times everything, is it just your doubles?
Yes. Anything times 2, you're just doubling it.
So if like 6 and 6 is the same thing, but you add them together, then it be 12.
Yeah. Yep. Grace? Yeah. Go ahead and make this in your notebook. That's fine. Courtney, what's up? Our yellow crayon. Mine's gonna look a little different because markers write a little different than crayons. We're gonna fill in all the products on our hundreds chart yellow. So what is the very first product I can color in? Nope.
2.
Raise your hand and tell me. The very first product I can color in. Lucy? 2. Just lightly shade in your 2, kind of like that. It does not have to be super awesomely shaded because we're going to do a whole lot of these. What's the next product I can shade in? Grace? 4. Hang on. What's next? Eva? 6. Okay, not ready. Come on.
We're kind of like 2.
What's next? Tyshir?
8.
8. What's next? Ryan?
10.
10. What's next?
12.
Say it out loud. What's next?
12.
What's next?
14.
Next.
16.
Keep going.
18.
Keep going.
20.
Keep going.
22.
Keep going.
24. 26. 28. 30.
What are we starting to notice? What are we starting to notice? Grace, you're kind of on this money already. What were we starting to notice? Georgiana?
I was starting to notice that they go in a row and just keep counting by 2.
Yeah, if we look, we kind of are starting to see some columns starting to appear. Susie, what are you seeing?
I'm seeing on the 10th on by 10.
Sure. Go ahead and color the rest. If you see the pattern, you're more than welcome to kind of color in by that pattern. If you need to go by 2s every single time, go by 2s every single time. That's fine. We're going to fill in our multiplication chart, and we're going to fill it in vertically, up and down. Go ahead on your math notebook, dog ear that page, so that way when we keep filling in our chart, you'll be able to easy peasy find it in the future. We're going to fill in our 2's in the vertical column. So 2 times 0, 2 times 0 is going to give me what?
0.
2 times 1, 2. 2 times 2, 4. Remember we double. 2 times 3,
6.
2 times 4,
8.
2 times 5,
10.
2 times 6,
12.
2 times 7.
14.
2 times 8.
16.
2 times 9.
18.
2 times 10.
20.
Is there anything else I can fill in my multiplication chart? Is there anything else I can fill in my multiplication chart? Brian,
Yes.
what else can I fill in?
Fill in another row.
What row? Random row?
No.
No. What row?
Another column.
Another column or another row? Column? Row? Where? Give me a number. This 4? This 4. At our other 2, Brian is saying we can go across. Is he right? Kaylin,
Yes.
prove to me he's right. Which says what? I can go any way but E. No, I can't. The commutative property says I can go in any direction. I can flip-flop my factors, but my products won't change. So even if I do 2 times 3 this way, what's my product?
6.
2 times 4?
8.
2 times 5?
10.
2 times 6?
12.
2 times 7?
14.
2 times 8?
16.
2 times 9?
18.
2 times 10.
20.
You guys got a lot of this multiplication chart already filled out.
I know how to count by 2.
Awesome. Awesome. I want you with your counters to create a yellow 2x2 and a red 2x2. Okay, now what's that? Yeah, but not right. We'll fill it in. Just fill it in. I don't see very many 2x2s. I need a yellow 2x2 array and then a red 2x2 array. Susie, that is a 1x2 and a 1x2. Yellow 2x2. And then a red 2x2. So we're turning our red 2x2 into a yellow 2x2, and we smushed it together. So we went from a 2x2 plus a 2x2. What did we make now? What is that? What is that array? Dylan, what did we make? What's that array? I mean, what's that equation? Nope, that's not a 2x2. We had a 2x2, and then we made them all yellow. So now we have a 4. 4 by 2. 4 times 2, which equals what? 8. We're going to start doing our 4s now. Yay! What do you notice about our 4s? Let's do this. Let's make a 2x4. Yeah, 2x4. Make a yellow 2x4 and a red 2x4. So we have a 2x4 and a 2x4. What does 2x4 equal? 2 times 4, 2 groups of 4. What does 2 times 4 equal? Dylan? 8. I want you to turn one of your counters, either, that's not how I have it arranged, because that is a 2 by 8. I want a 2 by 8. I want you to turn one of your colors, either to red or to yellow, and I want you to make it a 4 by 4. So smush your array together to make it a 4 by 4.
Do we still have the same color?
It needs to now all be the same color. You should just be flipping them over. So instead of having yellow, I'm going to change this to be red. And now I have a red 4 by 4. What does 4 by 4 equal? What's 4 by 4 equal? Eva? Nope. Your counters are not arranged the correct way. You have made a 2 by 8. I don't want a 2 by 8. I want a 4 by 4. Count your rows, count your columns. Damien?
16.
You don't have a 4 by 4 though, dear. You have a 2 by 8. Look at your rows and look at your columns. 4 by 4, Damien, you are correct though. It does equal 16. What are you noticing? Keep it up, you'll be out. What are we noticing? We went from a 2 by 4 and 2 by 4, and now we got a 4 by 4. 2 by 4 equals 8, so 4 by 4 equals 16. Okay, here, what are we noticing?
That every time you add, well, every time you multiplicate, it goes up 4.
Yep. Every time if you were to keep going, it would skip count by 4s. Sure. Grace, what do you notice? How did we get our 8? Grace, you're on the right track. She said, well, when you doubled it, you got 8. And so to do the 4 by 4, you just did your 2 8s together. So what does that mean? McKenna?
I see an addition problem in there.
Yeah. Yeah. Alright, let's revisit our hundreds chart. This time I want you to get out a blue crayon. And we're going to skip count by our 4s.
What type of blue?
I don't care what kind of blue. And I'm going to use my blue to only color in my 4s. What's the first product I can color in for 4s? Gabriella?
1.
No?
4.
4. 4 times 1 is 4. Go ahead and color in 4.
Again.
Color it in. What's the next product? 4 times 1 is 4. 4 times 2 is, Courtney? 8. 4 times 3. 4 times 3. Brian?
12.
12. 4 times 4. Susie?
4 times 4.
16. 4 times 5. Grace? Hang on to it. What's 4 times 5? Grace? 20. 4 times 6. McKenna?
24.
24. 4 times 7. 4 times 7. Mason? 28. 4 times 9. Parker?
32.
32. 4 times 10? Wait, what did I skip? I missed 4, no, I said 4 times 8, 4 times 9. 4 times 8 is 32, 4 times 9 is, Susie, what do you think? 36. 4 times 10, Gabriella?
30.
No.
No, wait.
4 times
40.
4 times 10 is 40.
Anything.
Are we noticing anything? Take a look at what you've colored. Are you noticing anything? Yours probably looks more like this. Oh, why is that not green? Probably these are all green because yellow and blue mixed together. Grace, what are you noticing?
I'm noticing that when you say 2 plus 2, it makes 4. So that causes every time you do 4 times 4 times, it goes up and it ends up 4. And the product is always a even number.
Okay, so we got a lot of even numbers. Lucy, what do you notice?
I noticed that there's still all even numbers and not odd numbers.
Yep, we still got all even numbers. Georgiana, what are you noticing?
I'm noticing that we have 2. It like goes 2, 3, 2, 3.
So the pattern, we're kind of skip counting every so often. Diane, what are you seeing?
Well, I see on my chart that it's 2. So when it's like you're missing 1 each time.
Aiden, move the counters to my table. Thank you. Cord, what are you seeing?
That they're all on diagonal.
They are going diagonal. Do I have any 4s that are not already colored? No. Do I have any 4s that are going to just be blue? They don't have yellow underneath. No. All of my 4s are also going to be my 2s. Are all of my 2s going to be my 4s? No. I'm not going to color in all my 2s. That would just be doing my 2s again. So let's think about this. We learned that when we multiply by 2, we double. Right? Yes? No? Yes. When you multiply by 4, you're going to double the double. You're going to do double doubles. So if I do the equation, let's go back to my page 3. Go ahead and write that in your notebook. 2 times 3. 2 times 3, we know because we're multiplying by 2, we're going to double that 3, which means our product is going to be what? Say it out loud. 6. When we take the same factor, but instead of multiplying it by 2, we multiply it by 4, we're going to double that double. So 4 times 3 is going to be what, Mason? 12. For 2s, you double. For 4s, you double double.
You force double.
You don't fourth double, you just double double.
Double.
Not gobble gobble, double double.
Gobble, gobble.
Double double. So let's try another one. Let's do something really crazy. Let's do 2 times 10. See if this works. What is 2 times 10? 10 doubled. It's going to be what, Taylor? 20. Now remember, to do our 4s, we have to double this again. 20 plus 20, or 20 doubled, is going to be what?
40.
4 times 10 is 40. Crazy. Crazy. Courtney?
It sounded like you're at 10, and you count like, it's got like 40 more, not like 40, like so much more. Count 4 times.
Sure.
Then you get 4.
Alright, so I want you in your notebook to write multiples of 4 equals double the double.
Oh my. Oh, that's smart.
Is it?
Yes.
This is why I tell you, don't memorize your multiplication facts. Could you have memorized your 4s or your 7s?
Yes.
Yeah, you could have, and that would have been fine. But for the rest of us who don't have their 4s or 7s memorized, is this a pretty cool strategy to use?
Yes. Yes. Yes.
Yeah, let's try one more and then I'll get to you, Aiden. Okay, let's do a really tricky one.
Oh. Don't
Ooh.
4 times 12.
I know the answer.
I don't know my 4s. Stop talking while I'm talking. Write this in your notebook. I don't know my 4s. I'm not a good 4 skip counter. I will admit that all day long. I can do 4, 8, 12, and then I get stuck. I am not a 12 skip counter. I don't think anybody really is a 12 skip counter. Maybe you are. Stop. What math fact can I use to solve 4 times 12?
Addition.
That's not a math fact that we're going to use. We're not going to use repeated addition. We're going to use a multiplication equation. Court? We can break it. We know that with 4s, we can use our 2s. 2 times 12. You should know that. What is 2 times 12? What is it, Court? 24. Can you use this math fact to figure out 4 times 12?
Yes.
Yes.
Give me a secret sum for some mental math. If you can figure out what is 4 times 12 using what you know about 2 times 12. Mason, what'd you get? 24 double. You can use your 2s for just about anything.
Yeah.
All right, Aiden, what were you going to tell me?